Hi everyone, very good morning and good evening. So we'll start the session, guys. Let me share my screen. Okay. So, so in the last session we see that. So we saw that related to how to automate the continuous ingestion process, right? So today what we are going to do is we are going to see how to work with the JSON data. So when we are loading the data from AWS to Snowflake, we have converted the JSON data, then we have loaded. But let's say here today, we are going to see if you wanted to load the JSON data directly into the table in semi-structured format into our Snowflake table, we wanted to load JSON data directly. So this will be taken care in the form of semi-structure format. When you wanted to load the semi-structured format into the tables, directly into the tables. But what we have done previously, so when we are implementing the copy command, we have converted, then we have loaded the data to our respective the target tables. So our target table is a structured table. For example, this is a structured table. So we have converted and then we have loaded the data. Let's say we wanted to load directly so to our Snowflake tables in the JSON format itself. Then what you need to do is in the table, we are going to create data type called variant data type. Variant data type. These semi-structured data, so we can load it into variant data type. But most of the time, right, only you are going to load the data into the table variant data type only if you are preserving the data for archiving purpose. It means if you are not accessing very frequently the data from the table, then only you will load the data into the variant data type, because when you load the data in the form of variant, then what will happen is the format, it will be in a variant data type, then storage will be very less when compared to the other data types. That's the main intention of the variant data type here. But when it is coming to here, when you are working with this, the JSON, if you wanted to load the same JSON data, we need to create variant data type. Then only we have to load. Here, once we have loaded, so how you wanted to read the data, then when we are reading the data, same way how we have implemented the flatten command. So nothing but we are going to use flatten option to convert the data into the structured when you are specifically reading the data. And if you have nested values, then you will use flatten. If you don't have any nested values, then you will convert into the structured format. So by using like a colon, column name, double colon, data type of the target, like that, we are going to use conversion. But if you have nested values, then you are going to use flatten command. So today we will see how to handle the JSON data and then how to load the data in the semi-structured format into the tables with the help of variant data type. And then if you wanted to load it, and then how we can able to load it, so how we can able to read it back, so we are going to see that. But most of the time, remember this, especially if your data is archiving purpose. So if you are not utilizing very frequently, most of the time, then only we will keep that the data in the form of JSON format. Otherwise, some of the applications, they will send that format in the form of JSON data, then you will convert and then you will load. So for the any intermediate tables, we are going to keep that. After that, we are going to convert it. So before that, what you need to understand is we have to understand the format of the data first, the JSON format of the data. Based on that, we can able to build the structure. For example, if you observe here, this is the sample JSON data. Now you can observe this from here to here. Let me copy this one from here to here. This is our JSON data. Now when you observe this, the JSON data, let me come here. See this. Let's try to understand this JSON data first. If you observe, we have person full name and then person age and then person gender, and then we have a phone number of the person, and then within the phone number we have two values. One is, if you observe, one is area code, another subscriber number. These are the two things, area code and then subscriber number. These are the two things. And at the same time, if you see, this is the person name, age and gender. This particular person have children's. When it is coming to the children, see this one. Again, the children, we have multiple values. From here, the square bracket, it will start the children details. From here to here, it is one children details, like children name, gender, age. And then another one is from here to here, other children details. See this one. This is the second children details. And the next one, from here to here, other children details, right? There are three children details here, like children 1, children 2, and then children 3. And then at the same time, children's where they lived in. This is another nested value. So this one, children's lived in. If you observe this here, from here, so again we have a sub array, city name, and then related to years lived in. So here, when you observe, cities lived in and then years lived in. Cities lived in is the higher array, and then years lived in is the lower array. See this one. Within this, we have again subarray. We have years lived in. These are the years lived in within this London city. Again, these are the years lived in within this Portland. Again, when it is coming to this, these are the years lived in. These are the city Austin, right? So based on these details, so we can say that, so here, so we have subarray, lower array, and then higher array. Higher array is city's name, and then lower array is years lived. All these details, whatever the details we are seeing here, this related to one person, particular person details, right? The person name, age, and then gender, phone number, and then children details, and then children's where they lived in, and then which years they lived in. These are the details which they are having. This is like JSON data, right? Now the recent days they're asking, so how we can able to like read the JSON data, and then how you can able to flatten the data. So these are the interview questions they're asking. Let's try to understand. So how we can able to, but remember one thing, most of the time when you are loading, so very frequent utilization, you will convert and then you will load. If you like using this for the just for the historical purpose, just for the preserve, like you wanted to archive the data, so you wanted to keep this data for historical purpose, then you are going to keep it in the form of JSON. So most of the time, if you wanted to read very frequently, then the only the option is we are going to convert into the structure, then we are going to read it. That is the best option. Now let's see, if you wanted to load this particular JSON data into the table in the same format, then what you need to do is we need to create a data type called variant data type. Then only we can able to load the data. Now let's create a table structure for this particular JSON data. What you will do is, so we are going to create a variant data type table. Observe this one, create table, table name, and then we are giving the column name. This is the column name. This is the data type, variant. Observe this one. This is the data type, single column, and then data type is variant. Now we created a table. Now if you observe the table, see this one, how it looks like. See this variant, right? So, and then this is a single column, variant data type. Now we wanted to load this JSON data into this table. Then we are going to use parse JSON command. When you wanted to load this, we are going to use parse JSON command, especially when you are loading the data to our JSON table. So let's see. So when we are using parse JSON, when you wanted to insert the data into this table, what you need to do is observe this, insert into the table, and then we are going to use parse JSON. This is the way how we are going to insert the data into the JSON data into our table. Now let's see this, what we are doing here. We are using, see this one, insert into the table, select. This is the command we have to use, parse JSON. So we have created a table with a variant data type, and then we are inserting the data into this table by using parse JSON command. When you are using parse JSON, observe this one. This is the same structure we have given here, parse JSON. So, and then this is the complete the data set what we wanted to load. This is related to one person records, right? If you have multiple values, then again you will have a comma, and then again you will have a multiple values for everything. So you are going to use parse JSON. When you load the data into the table, now see this one, when you use insert the data into this table, now the data has been loaded into this table. If you try to read this, this is in a variant data type. You cannot able to read the same as a structured format. See this one. If you see how the data looks like, this is the data looks like in a variant, because this is a semi-structured data, right? Most of the time, to preserve the data, we will use it in this particular format. But let's say we have sorry guys, give me 1 second. Okay, let's say we have a data into the table, but what we want is, so we wanted to read the data from this particular JSON table. Then how we wanted to read it? Okay, we have loaded the data, but maybe going forward we wanted to read the data from this JSON table. So if you wanted to read, we have to use conversion. So we need to convert the data, then only we can able to read it. Let's see how we can able to convert it. So when you are using this, like we saw that when in our the JSON format we have used, select column name, like a $1 column name, double colon, data type of the target we have given, right? The same way, see this one, select, this is the column, this is the column name, colon. So what you wanted to read from the JSON data? I wanted to read the full name. From where? From this particular table. If you give this conversion, then you can able to see in this format. But I wanted to, like, so read it properly. I mean, the name, it has to be display properly, and this one, so I wanted to display in the form of string. Then what I can do is, we can use in this format. See this one, select v, nothing but a column name, colon, what is the column you wanted to read, and then how you wanted to see this data, double colon string. This is how I wanted to see the data. And what is the alias name? So for this particular full name you wanted to give, I wanted to give alias name as a full name. So this one, otherwise if I don't do this, otherwise you will get the column names like this. But what you are doing here, we are converting in a proper way. So v colon, and then we are giving the column name, and then we are giving the double colon, and then this is a string as full name from JSON table, right? Now observe this one. Now what you observed, we can able to see this is a full name, this is the name of the person, right? We can able to read it properly. The same way I wanted to read the person full name, and then person like age I wanted to read, and then at the same time I wanted to read the other values. Yes, we can give the other columns also. Now let's observe this one here. Let's see, we wanted to read see this is related to the name. We are giving alias name as full name. This is related to age, person age. So we are going to convert this into the form of int, and then this is a age. I wanted to see this in the form of age, and then gender, and then this is gender, and then from this particular table. Now when I execute this, observe what will happen. See this, we can able to see, right? So this is the full name, the age, and then gender, right? So we can able to see the data here, right? The proper way, how we can able to see that in a proper way. So if you have only one value, you can able to see that. Let's say we have the within the phone number you have multiple values, sub values. So let me observe this. So here what you are going to do is we have within the phone number you have two values. One is subscriber number, another one is a like area code. See this one, phone number dot area code, phone number dot subscriber number. If you observe here the data, see this one, within the phone number we have two values for the phone number. One is related to area code, phone number dot area code. Another one is subscriber number. These are the two values belongs to only the phone number, right? So for this, what we are doing here, so we are specifying this the data in the form of this one. Observe this one. Select we are using in this form, right? Select phone number dot area code colon string area code. So and then at the same time phone number dot subscriber number double colon string subscriber number, right, from this particular table. So if you use this like this, then we will get the area code and then subscriber number. See this one from this phone number. So let's say if you don't have any values, so for the JSON, if the value is not available, let me show you. For example, it will be like this. Let's say I will give another value. If you don't have the value, like I will give instead of this phone number dot, I will give this as a fax dot fax. Then I will give this as fax. Now observe this one. If I give like this, is, is this value is available in our JSON data? No, right? Only the two values is available. So within the phone number, I have a area code subscriber number only. Whatever you are trying to read, this phone number is not available. When you are trying to read like this, right? So it won't have any values, then you will not get any values. What will happen is in this process, see this, you can see just null value, but it will not throw any error. Remember this. If the value is not available in the JSON, then it won't throw any error. Just it will give null values for that particular column. Okay, this is clear. Now, let's say here, if I wanted to read the nested values, so then how we can able to read it? Now we are reading all the like a phone number and then like a main l- person name, age, and then gender. We are reading these values. My requirement is I wanted to read children details. If you observe the children, how many children we have here? Three children. Children one, children two, children three. So how to read this then? Now when I use children, then this is first children, second children, third children. How to differentiate it? Here one thing we need to remember, when you are reading this, the nested, this kind of nested values, 0 represent the first value. Children 0 means that is related to first value. This is related to second value. 1 means related to second value. 2 means related to third value. It means it will start with 0. 0 means nothing but first, 1 means nothing but second, next will be third. So when you are representing children within the square bracket 0, that is going to point out to first value of the name. This is if you are specifying 1, then will be the second value. So second nest, then will be the third nested value. Like that, we can differentiate it here. Now let's see this. So how we can able to see this data? Let me, for example, see this one. Here, if I wanted to read first values, children here, we are using in this way. V colon, see this one, children 0 dot name. The names, the children names, I want the first children name. It has to be in the string, and then if I want alias name, children name, as I will give children name. I will give like this. See this one, if I give like this, then we are going to get children name, first children name, right? The same way I wanted to get the other children name. Then what I can do, I can give the union operator, then children 1, children 2, children 3, right? Now observe this one like this. We are going to get all the children values. I don't want to read the one, I wanted to read all the children values. Observe this, children 1, children 2, children 3. But let's say if my table is having multiple values, multiple nested values like this, it's difficult to write the query like this, right? For example, if I have like 50 to 100 sub values like this, then it is difficult to write all the union function like this. Then how we can able to handle this? If you have any nested values, we are going to use flatten command, flatten function in our Snowflake. This is very important. So this will be asked in like interview questions, how we can able to read the nested values. We are going to use flatten command when you are implementing the nested values. Remember this. Let's see. So how we can able to implement it. If you are using this flatten command, right, then no need to use this union operator. It will be like this in this form. Let's observe the last one. See this table flatten. What you are flattening? Children details. Children details I am trying to flatten. It means it has to how many children values is there. It has to get all the children values. It has to list down. That is the meaning of this flatten. And we are giving the alias name for this table flatten function as f. That is alias name. Now, if you observe what all the values you wanted to flatten, what all the values you need to list down. I wanted to list down children name, children gender, children age. We have different three values, right? Name, gender, age. So these values I wanted to list down how many children's, what are the genders, and then what is the age. So what you are going to do is in this case, we are going to use, see this, we are implementing flatten function here. Along with that, when it is coming to this, we are giving alias name as f. When it is coming to here, f dot value colon name. See this one, f dot value colon name double colon string as children name. Children name. Next one is children gender. For everything we are giving f dot. Observe this one, f dot. This is nothing but a flattening, right? We are using flattening the data. F dot value age string as a children name, children age, and then children gender. All these things we are flattening. All these three values we have to flatten the data. It means it will going to list down all the values. Now let's execute this one. When you execute this, what will happen? Let's observe. You can able to see children name, children gender, and then children age, right? So we have all these three values which it is available for us. Clear, right? So this is how we are going to flatten the data. See this, when you use this, the flatten function, no need to use the union operator. So like this, we can able to implement this flatten function. Now again, one more thing here. If you observe, see this carefully. Here, if it is a one higher array, we can flatten. Here, if you observe, this is sub array. See this one, cities lived. We have a cities names. Within that, again, sub array as years lived. By using this square brackets, right, we can say that this is a sub array. This is a higher array. From here to here, this is a like a higher array. Cities lived in, right? That is a higher array within the cities lived in. So we have years lived in. See this is a years lived in. For every city, there is a years lived in. This is a sub array, right? Lower array, we can say that. Now, there is two nested values, higher array and then lower array. Then how to read this? Then what you are going to do is, we have to again, so when you are have to nested this again in this higher array and then sub array values like this. Let me show you. See this one. This is a format we are going to read it. This is all how we are going to read the data from the JSON table. See this one here. This is cities lived CL. YL is nothing but years lived in. And then when you observe this, the JSON data, see this one. From the JSON table, what you wanted to read, see this, cities lived in. So this is a cities lived. This is a higher array. Within the cities lived, again we have a years lived. That's the reason, see this cities lived dot value, years lived in. For this we are assigning as a years lived, years lived in. This is a nested array. This is a higher array. This is nested array. So now from this higher array, cities lived in, we require the city name. From the lower array, see this nested array, we required years lived in. So that's why years lived in dot value. When you give this, so we are going to get cities lived, how many cities they lived, and then what all the years they lived in, we are going to get the values. Let me just a minute. Let me comment this. Let me execute this one.
Yeah, it got changed.
Sorry, this one has been changed. Years lived. Thank you. Now when you observe this, you can able to see this one, how many cities we have, every city, what all the years they have lived in. So we have this city name is a like higher array, city name is a higher array. Within this city name, this is the nested array, right? For every year, every city, what all the cities they lived, and then what all the years they are going to like they have lived in. So we can able to see this data. This is how, so we can able to read this all the JSON data. So let's say, for example, I don't wanted to read it. Let's say once we loaded the JSON data, every time when I wanted to read it, so from the same table, you no need to do like a conversion every time, right? What you can do is you can create a like a temporary table like that, or transient table, whatever it may be. You can keep the data there. For example, what I will do is I required these details like a children details, or I required this like this, whatever it may be, the details. Now what I will do is create temporary table. I will use my JSON as, see this one, just I will use till here. Then what will happen, whatever the data is you are going to convert, this will come to this particular table. Now when I read the data from here, then what I will get it, I can able to see the data every time in the proper format, right? Every time I can able to see that, no need to convert and then no need to read it every time, right? So if any situation, if you wanted to read it so frequently, then so once you like have this syntax, then so we can able to create it as a temporary or transient tables, then we can able to read it very frequently. So like that we can able to so handle the JSON data. And at the same time, we have so many things we can able to perform. We can able to implement like group by condition, aggregations, and then we can able to see like filtering the data also. For example, see this one, this aggregation related to the cities lived, how many cities they lived, and then so years lived. So if you observe this, see this group by, we are doing the group by based on the years lived, how many years they lived in each and every city. These are the four cities, and then how many years they lived in. So we are using a group by function. We are using a count star based on that, right? The same way we can able to use the filtering the data also. The same like our queries, what we are going to do, see this one, filtering the data. We can able to filter the data by using a, sorry, where condition like this. So we can implement it and then we can able to read the data properly. And then whenever you are required, so we can able to like keep it in a separate table and then we can able to so make use of this. But most of the time, remember, when you are dealing with JSON data, most of the time, especially when you are preserving the data into the tables, then we will use the JSON format. Let's say if you wanted to read it very frequently, then it's a better way to convert into the structured format, then we can able to read it. That is the best option. So, and at the same time, so when we are working with this kind of JSON data, first we need to understand, so what is the purpose we are doing it. And then so whether you are going to read it very frequently, or on top of this we are performing any kind of views. And then if you are very frequently when we are using, then so based on the requirement we have to handle it. But mostly for the archiving the data we will use it. If you wanted to get the details from the archived data, then we are going to use this conversion by using this the flatten command, especially when you have the nested values, then we are going to read it. This is the how we can able to read the JSON data. The same way, so we have XML also. So this is also the same option, you can try it. This also we are going to store it in a variant data type. But one thing here, in XML, it's very easy to read the data. See this one. This is the column name. This is the column ending. This is the value. Action date. This is the action date column starting, column ending. This is the value of the action date. This is the format of the XML. If you observe, see this issue date. This is the issue date. This is the date ending. This is the value of that. The same way, see this one, maximum single bid amount. This is the value, right? This is the end of the column name. This is the column name. This is the value. In between you have a values. So by seeing this, you can able to read it. Very rarely, so if you get the XML file, this XML file also we are going to load into the form of parse XML data. See this one, parse XML. Then we are going to load it into the table. Again, when you wanted to read it from the XML structure, then what you can do is the same way how we are reading the by using a flatten command implementation, we can able to read the data. You can try this once, the same approach what you have done, the same thing you can able to practice this. This is also the same format. And the main importantly we will see, so when it is coming to the Snowflake, right? So we have a constraint. In other databases we have like primary key constraint, and then not null constraint, and then check constraint, right? These are the constraints it will be there. Snowflake also we will have constraint, but remember this will be your certification question as well as interview question. Snowflake by default it will enforce enforce not null constraint. Only not null constraint Snowflake is going to enforce. It will not enforce any other constraint. You can even create a primary key constraint, you can create a unique constraint, but it will not enforce. The reason behind this is going to be a columnar storage format. What will happen, every partition overlapping is possible, right? One partition value it can be available in other partition also. That's the reason if you maintain this kind of primary key concept, then it is difficult to maintain the columnar structure format. That's the reason this will not enforce primary key constraint or unique constraints here. But even you can create it for the logical representation, but it will not going to enforce. Remember this one. Let's see so how we can create this constraint, but how it is not going to enforce it. So let's understand this. So let's say here, for example, generally if you create a table without any constraint, we will create a table here. Let's observe this. When you create a table, we are going to use the column names and then data types like this without any constraint, right? Now this is a plain table. So if you wanted to see whether any constraint has been, like let's say like constraint is created or not, we can use show constraint name and then for that particular table. See this one, show primary keys in the table emp. If I use this, now I can see this, there is nothing, right? We don't have any constraint here. Now if I wanted to create any constraint, once a table is created, later we can create it. That is the one way. Otherwise, during the table creation also, we can create a constraint. That is another way. Let's see. So one thing is, during the table creation itself, we will see how we are going to create a constraint. See this, we are trying to create the table with employee ID. The data type is number. For this, we are specifying primary key. Normally, in any other traditional databases, what is the purpose of the primary key? It will not allow duplicate values. It will not allow null values, right? It should not allow null values. It should not allow duplicate. That is the basic criteria of the primary key. But here, see this, we are creating a primary key. Sorry, guys. We created a primary key, right? We have created it. Now, if I see show primary key on a table, now I can see this one, database name and then schema name, which table the primary key is created, what is the column it has been created. At the same time, you can see constraint. See this one. But here one thing, if you observe, the constraint name properly not defined. It is not defined properly. If you wanted to define this properly, I mean, I want the constraint name for which column it has been created, then we have to define in a different way. So first we need to create a table. Later, let me show you. Once you create a table, later on we can create a constraint like this. Observe this one. What I will do is, first I will create a table structure, recreate the table structure. Here I didn't specify any constraint here. Once the table structure is created, later see this alter table name. I am adding the constraint name because the constraint name I wanted to display like this, employee ID primary key constraint. Now this is the constraint name and then for the column of employee ID. If I do like this, now if I see this, now if you observe show primary key constraint on this table, now I can able to understand how the what is the key column. See this one, I can able to see the proper name. So this is the way how we can able to create if you wanted to create as a proper name. Generally, otherwise you can give the constraint name here. That also another way. But here if you wanted to the naming convention properly, we will do this. But anyway, we have a primary key, right? Now, generally what will happen if I create a primary key for this employee ID, this should not have any duplicate values, right? Let me try to insert some duplicate values here. What I will do is for that employee ID column, let me try to insert some duplicate values. I'm trying to insert, say this one for this employee table. So first, this is the first value I'm trying to insert. I have inserted the first value. Now, if I see the data here, see this. If you see the data, What you observed, we have one row, right? Same way, I am trying to insert again another value, another row again. Observe this. Again, it has been inserted. Now let's check the data here. See this, what you observed here for the employee ID column, there is duplicate value, right? So most of the time, right? So within the Snowflake, before the data is coming to the Snowflake itself, in the stage layer itself, we are going to avoid unnecessary duplicate values. So in the source system itself, we have to avoid from where the data is coming from. Is it coming from the ETL side, or is it coming from any other third party tool? We have to clearly indicate that. We have to tell them Snowflake will not enforce primary keys. You have to maintain the, you have to prepare that the data when they are sending, it should not have any duplicate values. Or in the stage tables, for example, by mistake we may get it out, by mistake they may send the duplicate values. Then what you will do is, in the stage table itself, we are going to create a condition, like in a procedure or something. Going forward we will see that. Then we can understand, identify the duplicates based on the key columns. If there is a duplicate, then we are going to reject, we are going to stop the process. So that the source team, again, they have to rectify it, they have to resend the data. That is the best approach what we will follow in Snowflake. Now here, this is kind of primary key, right? Let's say, for example, let's see, for unique key constraint, unique also, it should not allow any duplicate values, right, normally. So let me create a unique key constraint also. Let's see. So see this one, let me create a table with unique key constraint. See this, what I am doing here, for the employee name we are giving as a unique, right? It means it should not have any duplicate values. This also, it should not have any duplicate values, right? Now if I try to insert, see this, with the same name multiple times, observe this here. One thing is, observe the name here, same name. First time I am inserted the same name. For the name we have given the unique value, right? And then second time, if I observe, second time I also inserted the same name. Now if I see the data here, the table name is this one, mp underscore u. See this, now let me see the data. See this one, both the names are similar, right? But it is allowing. But actually in any other databases, if you create a unique key constraint, it will not so allow you, right? It will enforce, right? But here it is not enforcing. But let's see, what is the constraint which will enforce in Snowflake? That is only one thing, that is not null constraint, that will be enforced in Snowflake. Let's see, let me create quickly the not null constraint based on this, the data. Let me create a table. Sorry, observe this one, we are creating a table, and see this, for the salary column we are specifying not null. It means, what it mean by that, this salary, if I try to insert a null value, it should not allow, right? That is the meaning of this. This should not allow the null values when I try to insert a null values to the salary column. Now let's observe this. If I try to insert the null values into this particular table, see this, insert into the table, and the null values, if I try to implement the null values, see this, what will happen here? See this, it is throwing error. It is enforcing, right? Enforcing nothing but it is following the rules. Not enforcing nothing but it is not following the rules, right? It is enforcing. It means we defined as a null value, not null constraint, but you are trying to insert a null value. So what it is telling? It is throwing error. null result in a non-nullable column. This column should not be any, it should not have any null value, but you are trying to insert a null value. It is throwing error, right? So only the constraint which will allow in Snowflake is not null constraint. We have one more thing. Maybe they will ask, this will be in the interview question, they will ask, we have a concept of hybrid table, guys. Don't get confused. Like we have permanent table, transient tables, temporary tables, right? Like that, we have a concept of hybrid tables. This is recently introduced in Snowflake, but the most of the time no one will use. The main intention is if you wanted to use it, okay, in your project, must and should you wanted to use it as a primary key constraint, you have to maintain. Then what will happen is complete structure will change. Normally, when you use normal tables in Snowflake, it will store in the columnar storage. But if you use hybrid table concept, it will store in the normal traditional system like row level, the row format. It is going to store in the row format. But then at that time, then constraint will accept. Constraints will enforce, especially for hybrid tables only. Remember this one. But if you try to implement any hybrid tables, right? But here you cannot able to create it in your trial account, but this will be like for only for your like enterprise accounts. It means you have to purchase, then only you can able to do that. In the enterprise accounts only, trial account it is not possible. See this, if you wanted to create a hybrid table, you can create like this, create or replace hybrid table, like temporary, transient we will give, right? Same way you will give the hybrid table. Same way we have another concept of a dynamic table that is very useful table. We are going to discuss in the coming session. I will show you, especially for incremental data loading, we will use this instead of the materialized views. Before going to the dynamic table, we will discuss about what is the purpose of views, different type of views in Snowflake, and then why we won't use materialized views in Snowflake, why we won't prefer it, what is the restrictions, and then why you are going to replace that materialized views with the dynamic table concept. We will discuss that. So but here, if I try to create a hybrid table, observe this one, this is the concept. So when you use a hybrid table, it will enforce the keys. Okay, remember this. So maybe they will ask in interviews, okay, so if I wanted to enforce keys, then what is the option? We have a hybrid table. This is recently introduced, almost 6 months, 6 months before it has been introduced. But when I try to create a hybrid table here, trial accounts, it is not possible. Only you can create it in your like enterprise accounts. But only the thing is, when you use the hybrid tables, the complete mechanism will completely, it will be shifted. But you need to take care of performance issue, and then you need to take care of, this is going to be a, the instead of columnar storage, it is going to be row level storage. Then the performance, it is not good. So as per the Snowflake, and it is very costly. Okay, that's the reason no one will go for this approach. Any table, if this is mandatory to use, then they have given a option. Okay, that is the concept of hybrid table here. Okay, so these are the different the constraints, so we can use it, and then how we are going to work with it in our Snowflake, guys. In next session, what we will do is we will discuss about the data sharing concept and then data sampling implementation. We are going to see in the coming session. Let me stop it here. Let's come to the questions. Variant data type for sorting Parquet data to, yes, storing, yes, for any semi-structured. It is not only for the JSON. It can be XML, it can be a Parquet, it can be Avro, whatever it may be. So you can use this variant data. All semi-structured data, we can use variant data type, Ankit. No, we cannot read it. The Parquet data, that is a problem with the Parquet. Once it is stored in a Parquet format, it is not possible to read it like a JSON. So you have to, like, just for the storing purpose only you are going to use it. Again, what you need to do is from the Parquet, you need to resend it back to your like any other third party location, then you need to convert that into the JSON or the CSV format, then only you can able to read. Directly, it is not possible to read from the Parquet file. That is the drawback of Parquet. That's why we will say that Parquet is more secured. And when compared to JSON, Parquet will occupy less storage. Sorry, guys. Any other questions?
Hey, Mr. Bankit, are you able to hear me?
Yes, Sanket, tell me.
So, isn't this a big drawback that they are not able to enforce the keys like primary keys and foreign keys and other
Yeah, most of the
things?
time, right? Yes, you are right. But the thing is, what will happen is most of the time we are going to use it for the data warehousing purpose, especially
Correct.
for OLAP purpose only. We are going to use it for the Snowflake. All the like a traditional transactional system, we are going to handle it with the other things like ETL process and all those things. Just we will use it for the any transactional system. It is not suggestible. So only for the warehousing purpose, we will use Snowflake.
But then they are allowing to create the key, just like
Mhm.
it's unable to enforce
Logical
it.
structure. Yes, exactly. You are right. Just for the logical representation, like identification in between the relationship identification, we will use it. That's it.
Okay.
Yeah.
One more question for the regarding the XML, right? So sometimes XMLs are also very deep, right? I mean, they will also have hierarchical structure and embedded
Mm, 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 mm.
XMLs inside the tags, right? So we'll have to follow similar approach.
Yes, the lateral
Like,
flatten function is there. So with the help of the lateral flatten function, so we can able to nested the data. Same way like JSON, how we are nested the data with the help of flatten function, right? With the same thing, we can able to do it.
What is the advantage of storing the data in JSON format? Is it storage wise
Mm.
or
The main intention is a good question, Kalyani. The main intention is if you are storing the data in the structured format, it will occupy a lot of storage. So, but when you like store the data in the form of JSON format, it will store less storage. That is the main thing. Just for the like reduce the storage cost.
okay.
For example, in your organization, you may have like a 20 years of the data, 30 years of the data, it will be there, but you may not use all the data, only the recent 3 years of the data, recent 5 years of the data only you will use it. Remaining all the data you don't need, right? It's kind of um, like a cold data. So in those situation, so we can keep it in a JSON format.
Can we have a combination of JSON field and a non-JSON field in a table?
No, not possible.
Okay.
Any
Because we can
one
have,
format only we can do. Yeah.
uh, in Hive it is possible, right?
Oh, I'm not sure about it, but here, no, not possible.
Okay.
Okay, guys. Thank you. See you tomorrow. Yeah, bye.